All right, I'm going to attempt to make a review video for you. Explain how to find the next term in the sequence. It looks like they are going up by 3 each time. So add 3 to the previous term. And it says find the 10th term in the sequence. So I'll just have to keep listing. So I was on the 3rd term. So I'd have to go 4th, 5th, 6th, 7th, 8th, 9th, 10th. And I'm adding 3 each time. So add 3, 16, 19, 22, 25, 28, 31, 34. Looks like my 10th term. So this is a arithmetic sequence because you're adding a constant amount to the previous term. And write a closed or recursive formula. So if I wanted to write it as closed, I would write a sub n equals, and I would write my first term, which is 7, plus 3 times n minus 1. So that means I only add 3 after the first term. I don't want to add 3 to the first term. If you want to write it in recursive language, you could say a of n plus 1 equals a of n, because that would be the previous term, plus 3. And remember, we have to tell them where to start. So a sub 1 is equal to 7. So I hope you can read that. Question number 2 says, explain how to find the next term in the sequence. So again, it looks like this time we're multiplying by 3. Find the 5th term of the sequence. So I'd have to multiply by 3 twice. So multiply by 3. The 5th term, so let's see, 90 times 3 would be 270. So I have to do 270 times 3. So it looks like the 5th term would be 810, which makes it geometric because you're multiplying by a constant each time. Write a closed or recursive formula. So we're going to model it very similar to problem number 1, starting term plus 3 n minus 1. So this time, I think we actually wrote it without the subscript. I probably should write a parentheses n is equal to 10 times 3 to the n minus 1 power, very similar to exponential functions. Or I could write a of n plus 1 equals the previous term times 3, and I would need to say a sub 1 is equal to 10. All right, let's see. Explain how to find the next term of the sequence. Let's see. This one goes up by 2, 4, 6, and 8. So add 2, then add 4, then add 6, right? And so on. So add 2 more than the previous thing that you added. So let's see, the 10th term. So I've gotten to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just added 8. So I would want to add 10. So that was plus 10. Now I need to add 12. So I think that would be, is 39 plus 12, 51. Then I need to add 14, so that's 65. Add 16, that's 81. Add 18, it looks like the answer would be 99. And it is neither, right? Because I'm not adding a constant amount. Okay. Determine whether the following sequences are geometric or not. And if they are, we have to find the growth factor. So this looks like I'm multiplying by 10 every time. But if you forgot how to find a growth factor, you take the second term and divide by the previous term. So 70 divided by 7 is 10. You could also take 700 and divide by 70, and that would also be 10. So geometric, I have a growth factor of 10 times 10 each time. This looks like I'm adding 5 every time, so that's going to be not geometric, so I don't need to find a growth factor. This one looks like I'm multiplying by a half as much every time, so that's geometric times a half. Again, I could have taken 50 and divided by 100, and then I could take 25 and divide by 50, and that would give me a half. So this one I might not be able to tell. So what I can do is take 120 and divide by 80 on my calculator. 120 divided by 80 is 1.5. Now I can take 180 and divide by 120 and see if I get the same thing on my calculator, and I also get 1.5. So it is geometric with a growth factor of 1.5. All right, so in the next example, they want you to just find the term that they've requested. So it looks like A of n, so previous term plus 5, I'm starting at 10. So if I'm adding 5, it looks like the third term would be 20. Let's see, this just says multiply the previous term times 2. And I have to go all the way to a sub 6. So term 1, 2, 3, 4, 5, 6. I'm multiplying by 2. So negative 10, negative 20, negative 40, negative 80. It looks like my answer would be negative 160. This is the Fibonacci sequence. If you remember Fibonacci, we looked at it a little bit in examples in nature. Add the two previous terms, n minus 1 plus n minus 2. So they're giving you the first two terms. So 1, 1, I have to go to term 6. So 3, 4, 5, 6. So I'm adding together 1 plus 1 to get 2. 1 plus 2 to get 3. 2 plus 3 to get 5. And 3 plus 5 is 8. All right, let's see. This last one says take half of the previous term. And so we're at 40, and we have to go to a sub 4. 2, 3, 4. So half, 20, 10. So it looks like the fourth term would be 5. So now they're giving you closed formulas, and you have to find a term. This is easier because you can just take your number and plug it directly into the equation, kind of like it's an x value. So 3 times 4 is 12, plus 1 would be 13. Plug in 3 here and here. So you'd get 3 on top, and 3 plus 1 on the bottom is 3/4, or 0.75 if you got 0.75. Let's see, I plug in 4. So I'm going to get negative 4 times 5 in parentheses looks like negative 20. And it says, given 5n plus 5, find a of 3. So I plug 3 in here. 5 times 3 is 15, plus 5 would be 20. Which sequence in number 5 is this closed formula identical to? Well, if I plug in 1, 5 times 1 is 5, plus 5 is 10. And we're adding 5 every time, so it looks like the one in 5a is identical. And would you rather use closed or recursive to find a sub 100? So I would rather use closed because I can plug in 100. So if you have a closed formula, you can take it and directly plug it in. If you have recursive, you have to find every term leading up to it. Let's see, here's a visual pattern of dots. So you have 1, and then you're adding 2 more dots, so you have 3, and then you're adding 3 more dots, so you have 6. So it looks like I'm adding 4 more dots to fill this in. So I'm doing D3 plus 4 more dots. So 6 from the previous row plus 4 is 10, so I have 10 dots. For 5, I would take D of row 4 and add 5 more dots, because you always add the number of dots from that row. So 10 plus 5 would be 15. What values make sense for n? N can be any whole number, right? It can't be negative. It can't be a decimal. What values do not make sense? Negatives. Can't have a negative step. Decimals, right? Can't have part of a step. Complete the table for steps 1 through 5. So I've already done that.